Hi everyone, welcome to a new video. This is Sam, and in today's video we're going to talk about CI/CD pipelines, Sysdig secure, how to enable your developers to think of security as they're developing their applications, how to shift security to the left, and make sure that you're building with security in mind. This will be the first video in a 3-video series for different demos around Sysdig, how you build your application, how you run the application, and how you respond in case of issues. So let's get started with this first video. All right, so the first of 3 videos or 3 demos that I'm going to present. This is the idea here is to go through the life cycle of an application or life cycle of a container or microservices application. The first stage is your build stage, right? So you're building your application. You want to make sure that you do your image scanning properly, you hit compliance, look at your topology mapping, and so on. The second phase is after you've done all your vulnerability scanning, you've run or you've moved your images into production, and now you're running your microservices in production. You want to make sure you are covered for performance monitoring, runtime security and anomaly detection. And finally, if something goes bad, you want to know, or want to know how to troubleshoot, look at the forensics in case of a security incident, and also have auditing capability. So the first out of 3 demos, we're going to look at CI/CD with scanning, and in this case I have a development machine. I'm going to be running on my Mac, and then what I'm going to do is I'm going to commit a change that gets pushed to GitHub. Then a webhook triggers Jenkins to build my image and push that image into GCR, Google Container Registry. From there, Sysdig takes over, scans that image, and pushes that image to back to Jenkins. It responds actually with the result of the scan. So if it's a pass, Jenkins will take that and build a production image, and from there deploy that production image into production in your GKE cluster. If it fails, we get a report of the failure, and we can go through that report. And as a developer, I don't even need to log into Sysdig Secure. I can see everything in my Jenkins deployment, and I can see the report, and I can fix what needs to be fixed and continue on my way. So this really is shifting security to the left, fail fast, and build with security in mind. Now, for the sake of this demo, we're going to run on an application called the Hipster Shop. It's an e-commerce application. It was built by Google. I'm going to leave a link to the GitHub repo in the description in this video. And what we're going to do here, we're going to add a vulnerability to the front-end microservice. So I'm going to build the pipeline just for the front-end microservice. The beauty about this demo app from the Hipster Shop demo app, it's built out of 12 microservices and really is a good demo to show a microservices architecture in real life. So I'll add a vulnerability to the front end. I'm going to expose port 22 in the Docker file, which you should never do. And I'm going to add a password as an environment variable as well. And finally add a private key inside of a file. So doing all kinds of bad things that you shouldn't be doing in a production environment, just to show you how we're going to catch all these with Sysdig scanning capability. Alright, so let's move over to my CLI here. Let's exit out of here, clear. Okay, and I'm gonna go into my front-end service folder. I'm gonna open the Docker file, and what I'm gonna do is I'm gonna introduce a vulnerability here. So instead of using the Alpine image that's the latest, I'm gonna actually use an older image. So Alpine 3.4. And here I'm gonna expose port 22. I'm gonna copy a file as you can see here, that it's basically a private key stored in a file. I'm going to keep it in the image. I'm going to expose a password, and from the password here you can figure out how old my kids are. Anyway, so we're going to save this, and I'm going to commit this. Let's say I introduced vulnerabilities, and do a git push, and that should trigger things for us. Now, while we do this, I'm going to show you really quickly here in GKE. I'm running a cluster. It's a 3-node cluster. I have a bunch of workloads here. This is the hipster demo app that I have here. I'm running the different services, so I can go straight to my front end. But before we do that, just quickly, you can actually deploy Sysdig straight from the marketplace here at Google. So if you do a Sysdig agent search, you can see it here. You can configure the agent right from the UI, really give it a namespace and an app name. Here you need to put in the access key that you need to send the agent information to the backend, and you can enable eBPF support for the Sysdig agent. This is important to check if you're going to run container optimized operating system, COS, on GKE. Okay, so once you do that and you can deploy, that's one way of deploying our agent. You can also use an operator that we have available, or Helm charts, or plain old kubectl commands. Alright, let's go back, take a look at the application that we have here. So let's go to the load balancer, IP, and we have our hipster shop up and running. And notice that there's nothing other than hipster shop in the title, and because we're gonna iterate and put version 2 in here in just a minute. Alright, so let's go into our build, and you can see that the build just happened recently, and it failed. So what we can do, and the last one was a successful build. So why did it fail? Let's go in here and take a look at our report. We have a Sysdig secure report that we can quickly open, and we can see that we got 15 stop actions, 1 warning. The final action was to stop this build. This build was built in the front-end dev with this particular tag. So this lives in GCR, and this is the tag for it. But let's figure out why this failed. I see a bunch of vulnerabilities that have been identified as medium, and these are all stop actions in our gate for our policy that we've defined. But what else? In addition to the vulnerabilities, I see the dockerfile exposes port 22. That's a denied ports list that I have in the policy. I have an environment variable here that has a password, and I also have a secret, basically a private key in a file. We've scanned it and we found that this is something that should not happen, and we failed the policy. We can further go into the security tab here in Jenkins, and you can see the different CVEs that we saw earlier. It's worth noting here that in the policy we define that we will fail a build if there's a fix available. So the package that we've scanned is this version here, but there is a fix in 1.0.2 as opposed to 1.0.1. So with that fix in mind, you can fail the build, tell your developers that this failed, so you can go back and update the build. And that's what I'm going to do in just a second. But really key here is that we're actually, as a developer, I don't have to log into the Sysdig Secure console at all. Everything is done for me right here in the Jenkins console. So let's go back here. Let's open the Docker file once more. In this case, I will remove all the vulnerabilities that I introduced. And remove this and the password. Let's save that. Let's commit and say removed vulnerabilities and push. And let's take a look. This should take a second. And you'll notice that after this succeeds, that this will change the version of the front end that we're running to version 2.0. So now we see that the scanning has succeeded. We're pushing this to our prod, this image to prod, and we've deployed the app. So I can show you GCR in this case. Sysdig Anthos demo is where I have my repositories, front-end dev and front-end prod. And if I go into front-end dev, for example, I can see my image and the different tags that I have. And it's interesting that Google has not found any vulnerabilities in my images in the front-end dev, which is not true. We did introduce some vulnerabilities. We saw that earlier. Maybe because it's still in beta. That's why we couldn't see it. But here's our prod environment as well. And you can see that this tag has been pushed into prod. And if we go back to our app, let's refresh here. And now you can see hipster shop version 2.0 shows at the top. We've successfully deployed our app with a new version that we have here. So once again, this shows you the flow that we had with the CI/CD and how you can enable Sysdig scanning as part of your pipeline build and shift your security to the left. Make sure that not only are we looking at vulnerability scans, but also best practices in dockerfile. We can introduce NIST policies and PCI compliance policies as well, to make sure that your developers are compliant to whatever security policies you've put in place. So finally, let's take a look at that image scanning policy that we've implemented under this Google event demo name. As you can see, the vulnerabilities package, the way I defined it is if there's a fix available that's true and the severity is greater than or equal to medium, then we're going to stop the build. Another one here, if you expose port 22, I'm going to stop the build. Here are a couple that I'm only warning against. Here's where I'm looking for any private keys or any secrets that I might find in any files. And finally, an environment variable that might have a password in there. I'm also stopping this. So this shows you how you can implement a scanning policy that can enforce some of those policies that you want to see in place. We have a few policies out of the box, such as the default one, some Docker best practices, dockerfile best practices, NIST, and PCI. So hopefully this has been helpful for you guys to get an understanding of how to build your CI/CD pipeline with security in mind, having Sysdig Secure do your scanning for you, and enable your developers to make sure that they build with security in mind. Thank you for watching.